Hello, good morning. I'm Dr. Sonali here. We are here on Education on Cloud for class 10 science. We have a chapter named periodic classification of elements. Okay, so all of you are familiar why there is a need of classification, because if all the elements with different properties, different characteristic, appearance, if we kept it together, then if we wanted to search and if we wanted to study a specific kind of property of the element, then it is very difficult to find out from the 118 elements which is discovered till now. So that is why, if according to their properties or according to their electronic configuration, if they are classified into specific classes, then we can directly go to that class and search about that particular element and study about that. So that is more easy. That is why systematic and organized way of arrangement is called periodic table. So we have discussed about periodic table. Let's discuss quickly about all the periodic tables, which is like we can say genesis of periodic table from the beginning. In the beginning there was very few elements which was discovered, so that time the periodic table was made with the very few elements, and all the periodic table just before this modern periodic table based on increasing order of atomic mass. Only the modern periodic table which you are studying with 118 elements, that is there with increasing order of atomic number. Okay, so the first we will start. Early chemists classified elements as metals and non-metals. Okay, as here we can see it has come. So metals and non-metals. Okay, so according to this, the metals, non-metals and metalloids also will be there. Actually the properties in between metals and non-metals are called metalloids, basis of the set of physical and chemical properties. They are only called periodic table. Okay, so the very first periodic table was given by the scientist named Daubernier. Daubernier classified elements on the basis of law of triads. Okay, law of triads, which states that atomic mass of the middle element of a triad is almost arithmetic mean of other two elements. So they had kept three elements with similar properties in a group. Okay, in one group, and there what they made, the first element and the last element, if we take a mean of it, average of it, then we are getting the middle element's atomic mass, like that. So they had arranged according to the similar properties, like we can see here. For example, they had only kept it, this is one of the triad, lithium, sodium and potassium. If we say atomic mass of lithium is 7, atomic mass of potassium is 39, if we add it up, 39 plus 7, and divide by 2, okay, so we are getting 46 by 2 is 23. So the atomic mass of the middle of the element we are getting it, that is only called Daubernier triad. Okay, so triad of element is a group of three elements arranged in the order of increasing atomic masses. So you should remember very carefully, all the periodic table before modern periodic table was arranged on increasing order of atomic masses, such that group of elements will have similar physical and chemical properties. So these are now also in modern periodic table also, all these elements are in group 1, correct? So they are according to similar chemical properties, it is arranged now also, but that time according to similar chemical properties, and the concept was the three elements group was there. So the one group elements, first element and the last element's average atomic mass will only give the atomic mass of the middle element. Okay, like that. Then Learnyn classified elements on the basis of law of octave. Daubernier's classification was very limited to very few elements. Okay, and there were few drawbacks also. To come over that, there were few more elements was discovered, and to come over that, there is Learnyn, one more scientist named Learnyn has given the another periodic table, that is called law of octave. Why it is called law of octave? Like a musical notes, there will be a 8 musical notes, like the first and the last musical note will be same, like that. So here also the elements are arranged in such a way, the first element and the 8th element will have similar properties, like that. Okay, so we can see here, here very few elements was discovered, so it was arranged from lithium to calcium only. Okay, and according to this law, when the elements are arranged in the order of increasing atomic mass, again you remember here also order according to increasing atomic mass, the property of 8th element starting from a given element or a repetition of property of first element. So similarly, like a musical notes, it starts from sa, and if we say sa re ga ma pa dha ni sa, the last note is also a sa. So like that, the first and 8th note is same in a music. Same way here also, law of octave, the first and 8th element will have similar properties, and they have been arranged according to increasing order of atomic masses. So that is only called law of octave. Okay. Next we are studying the there were few drawbacks as well as very few elements was kept there, so studied there. So the next scientist was Mendeleev. Mendeleev is considered as father of periodic table. Why? Because maximum elements, like we are studying now 118 elements, out of that around 92 elements was discovered and studied by Mendeleev only, and despite of not having much facilities that time, and still technically we were not so advanced that time, still it could be the whatever studies has been done. Now if we use the advanced instruments and try it, so the properties are very close to that and exactly same properties. So the study was very perfect. So that is why Mendeleev is considered as father of periodic table. Mendeleev periodic table also classification based on the again increasing order of atomic masses of the elements and the similarity in their physical and chemical properties. According to this, the arrangement is done. Here is a tabular chart representing systematic arrangement of elements in groups and periods. Okay, so in Mendeleev periodic table, it was divided into groups and periods, and the groups was subdivided into further subgroups also, and the periods are also divided. So horizontal line and the vertical lines, groups and periods was divided like that. So there were 8 groups and 6 periods was present in the Mendeleev periodic table, and 8 groups was further subdivided also. Now Mendeleev periodic table is a tabular chart representing systematic arrangement of elements in groups and periods in order of their increasing atomic masses. Okay. Now in the original Mendeleev periodic table, if we see, there are 8 vertical columns called groups. Okay, there are 8 vertical columns called groups, and the groups from 1 to 7 are subdivided into 2 groups. Okay, and subgroups A and subgroups B. On the whole, there are 15 vertical columns. Okay, there are 15 vertical columns because of the subgroups A and subgroups B also is there. Now the properties of elements in subgroup or main groups are similar. Okay, they are arranged according to increasing order of atomic mass and similar physical properties and chemical properties also. The horizontal rows in periodic table are called periods here. Okay, so in a period, if we say, the properties are gradually changing from metallic to non-metallic character. So now in modern periodic table also, extreme left hand side you will see metals and extreme right hand side you will see non-metals, like that. So here also metallic to non-metallic characters. Then there are few gaps in the periodic table. The gaps were left knowingly, as these elements were not known at that time. Okay, so that gaps was also filled by Mendeleev, and he has studied already. He has studied. So when he died, till that the study was also completed for the gaps which was left, and on the paper the study was there that has been utilized to incorporate in periodic table. Okay, after his demise also. So H.G.J. Moseley, this is only the person who has given a modern periodic table. He has modified Mendeleev periodic table. Mendeleev periodic table also has some drawbacks to come over that, the modern periodic table. Now modern periodic table, very important change has been done from all previous periodic table is, it is arranged on increasing order of atomic number. Okay, why it is arranged on atomic number? What is atomic number? Atomic number is the number of protons which is always equals to number of electrons. Okay, so the properties are decided, chemical combinations, electrons are only taking part. So that's what this periodic table we can consider it is more appropriate, because it is arranged on increasing order of atomic number. Okay, so there is more fundamental property of elements. So the physical and chemical properties of elements are the periodic function of their atomic numbers. So 18 groups and 7 periods will be here in the periodic table. So the new periodic table is arranged in such a way there are 18 groups and 7 periods, and according to properties, similar properties as well as increasing order of atomic numbers, their arrangement has been done, and they are divided into 4 blocks: S block, P block, D block and F block according to their electronic configuration. So when outermost electron goes to S orbital, then it is called S block element. Outermost electron goes to P orbital, they are called P block elements, like that, and D block and F block elements. Okay, so each element in this has specific characteristics also, like S block elements are very good reducing agents. Okay, and we can say they are, most of them are metals in that, and except hydrogen. And P block elements has the only P block elements. P block is the only block where the metals, non-metals and metalloids all are present, and D block held all metals only. Okay, and D block there are 2 strips which is forming F block, which is the study is incomplete, that they are called lanthanide series and actinide series also. Okay, so we will see one by one now. And the noble gases which are non-reactive, inert, they are kept it in the last group, group 18. Okay, like helium, neon, argon, they are inert in nature, so they have kept it in the separate group. So in the modern version of Mendeleev periodic table, there are 9 vertical columns called groups. These groups are numbered from 0 to 8 and not from 1 to 9. 0 group consists of rare gases, was not known when Mendeleev prepared his original periodic table. Okay, groups from 1 to 7 are divided into subgroups A and B. Horizontally, periodic table is divided into 7 rows running from left to right. These rows are called periods. There are 7 periods in all. Okay. Now, modern periodic law. What is modern periodic law? It states that properties of elements are the periodic function of their atomic number, means they are arranged according to increasing order of atomic numbers. Okay. Now, Niels Bohr constructed the periodic table, commonly called as long form of periodic table. Why it is called long form? Because till now, before this, what are the periodic table was discovered has less number of elements. This periodic table has maximum number of elements, which was discovered till date and studied also. So 118 elements are there. Okay. Now, long form of periodic table is the elements are arranged in groups and periods on the basis of electronic configuration of element. So just now I said basis of electronic configuration, they are arranged in 3 we can say 4 blocks, S, P, D and F blocks. Okay. So here it is arranged such a way ki group number 1 and 2 will be in S block. Then these are the groups and these are the blocks. Okay. Now we can say here group 3 to 10 is D block, and then 11 and group 11 to 18 are P block, and F block is the strips in between, that is 4f and 5f series. So outermost electron goes to 4f orbital is 4f series lanthanides, and outermost electron goes to 5f orbital, that is 5f series actinides. So lanthanides and actinides comes under F block. These are called representative elements. These are also called representative elements. They have metals, non-metals and metalloids. These are called transition elements, and these are called inner transition elements. Okay. So like this, there are how many groups total? There will be 18 groups and 7 periods. Okay. So period group 18 which we say here in P block is noble gases. So noble gases are kept separately because their behavior is similar. They are inert in nature, they are rare gases, so they are kept it in separate groups. Okay. Now, if we talk about characteristics of the long form of periodic table, there are 18 groups in the long form of periodic table. Group 1 is on the extreme left hand side and group 18 on the extreme right hand side. So, it will look like this somewhat if we try to make it. Okay. So, here you will see this is S block, this is D block, this is P block, and these are F block. Okay. So, S block extreme left, P block extreme right, D is in the middle, and F are the two strips from the D only. So, extreme right hand side of the periodic table, group 1 to 13 to 17 contains normal elements, okay, and the normal elements are sometimes called representative elements. Okay. So, here we can say group 1, 2 are here and 13 to 17. Okay. Then in these elements all the inner shells have completely filled with electrons except outermost shell which is incomplete. Okay. Then the elements in group 8 electrons are in their valence shell except helium which has 2 electrons. So, here 2 electrons means it is called duplet. Outermost 2 electrons completion is called duplet, and here 8 electrons means they are called octet. Octa word is used for 8. Okay. Group 18 are known as noble gases. They have 5. The elements are in group 3 to group 12 are called transition element. Okay. We can say here, 1 minute. So, group 3 to group 12, if we can say, okay, then we can say here as well as the shell next to the outermost penultimate shells are incomplete. In transition elements what is happening, the incomplete d orbital also is present. Because of that their behavior and properties are very different. Why? Because they act as a catalyst, they have they act as they make complex compounds, they show colored compounds. So, many different properties transition elements exhibits. Characteristics of the periods, there are 7 periods. How many total periods? There are 7 periods in all. Such has consecutive atomic numbers. The number of elements in period corresponds to maximum number of electrons which can be accommodated in one shell. The number of periods of which elements belongs to given by the number of outermost shell. Okay, that is called quantum number. We have studied about quantum number also. Quantum number is the energy level which is from the nucleus. It is showing the how many energy levels are there. Bigger the principal quantum number value, n is equal to bigger the value, bigger is the size of the atom. So, if n is equal to 4, sizes means there are 4 energy levels. N is equal to 1 means there is only 1 energy level. So, the size is small. Rare earth or lanthanides, they are inner transition elements from atomic number 57. Okay, from d orbital only, atomic number 57 to atomic number 71, lanthanum to lutetium. Okay, they are kept outside the periodic table to mark their peculiar properties. They are called 4F series. Actinides, they are inner transition elements, starts from atomic number 89, that is actinium, to atomic number 103, lawrencium. Okay, they are kept outside the periodic table to mark their specific properties. So, they are called 5F elements. Electron, outermost electron goes to 5F orbital. On moving from left to right across a period, the number of electron in valence shell increases by 1 in group 1, 2, 13, 14, 15, 16, 17 and 18. Okay. So, like we can see the example here. If we say group 1, electron, outermost electron will be 1. If we say group 2, outermost electron, group 2, one of the element we are saying, outermost electron will be 2, like that. So, similarly group 13, 14, 15, 16, 17, 18, 1 electron will go on increasing. Okay. Then we can say on moving from left to right across a period, the valency of elements with respect to oxygen increases in group 1, 2, 13, 14. Okay. And then it is 0 in group 18. What is valency? Valency means the outermost combining capacity, outermost electrons which takes part in chemical combination. That combining capacity is only called valency. Okay. Then on moving left to right across a period, atomic size of the element decreases, and in groups 1, 2, 13, 14, 15, 16, 17, and then suddenly increases. Okay. So if we say, here we are using the term left to right. Left to right means we are talking in a period. Top to bottom means we are talking in a group. Okay. You remember that this whenever we are talking left to right, that is we mean to say a period. Top to bottom, when we talk, we mean to talk about a group. Okay. So on moving left to right across a period, the metallic character of the elements gradually decreases. Extreme left, S block elements all are metals except hydrogen, and as we go right hand side, we can see non-metals like carbon, sulfur, oxygen. Non-metals are also present, metals are also there, but it is having a combination of metal, non-metal and metalloid than that P block. Okay, and so characters are decreases, and non-metallic character increases. Till the 18th group it becomes noble gas. Noble gas, 18th group is noble gas, which is not reactive. On moving left to right across a period, the metallic character of the elements gradually decreases and non-metallic character increases. Till the 18th group it becomes noble gas. Okay. Now across a period, the chemical activity of element gradually decreases, then it starts increasing such that the elements in the last groups are chemically inert. On moving left to right across a period, basic nature of oxides also gradually decreases and the acidic character also gradually increases. How it is decreases? Because extreme left, if we talk about S block elements, are highly basic in nature, and if we talk about their oxides are basic in nature, that's why they are called alkaline metals. Okay, and as we go right hand side, like oxides of chlorine and all is acidic in nature, like that. Okay, so similarly, then as one moves down a group, the number of electrons in valence shell in the group 1 and 2 are the same as the number of group. Okay, so if we say group 1, lithium, sodium, potassium, number of electrons are 1. Okay, so this shows the number of electrons shows they are belong to group 1. Okay, so if outermost electron is 1 means they are belong to group 1. If outermost electron is 2, they belong to group 2. More than that, group 3 onwards, what we are doing, 13 to 18 is equal to the number of group minus 10. Okay, so if we do it, then all the elements in group have same valency, which is equal to the number of electron in valence shell. So if they have to give this electron and form a cation, they will form Li plus, Na plus and K plus cation, because outermost has only 1 electron, and they are very good reducing agent. They can lose electrons very easily. S block, the atomic size of the element increases as one moves down the group. So down the group, if we move, atomic size increases. Okay. Now while moving down a group in metals, the metallic character of element also increases. While moving down a group in non-metals, 14, 15, 16, 17, the electronegative character of non-metal decreases, because here we can see group 17. Group 17, if we talk, the fluorine is the most electronegative, then chlorine, bromine, iodine, like this. Okay, so this is most electronegative. In periodic table. Okay, what is electronegative? Which can have property or capacity to capture electron towards itself. While moving down in a group, metals, the chemical activity of metal increases, and while moving down in a group, non-metals, the chemical activity also decreases. The fluorine is most reactive, so laboratory reactions you will not see with fluorine many, because it gives instantly, it reacts, violent reaction it gives, and the reaction cannot be handled easily. So chlorine is the most lab friendly halogen, we can say, because mostly reactions you will study with chlorine. Chlorine can be controlled, the reactions can be controlled, it can be studied. Okay, so like that. So the chemical reactivity should be comparatively moderate, so we can handle it. While going down in a group of metals, the physical properties such as melting point and boiling point decreases gradually. While going down in a group of non-metals, the physical property, melting point and boiling point increases gradually. Like this we should remember. Okay, thank you.